Assalamualaikum and salam sejahtera. Today, I'll be presenting my research innovation entitled Waste-Derived Activated Carbon-Chitosan Composite as a Sustainable Solution for Wastewater Treatment. Before we begin, let me introduce the brains behind this innovation. Firstly, I am Aaron Zafri bin Nuzaki from the Malay College Kuala Kangsar, also known as MCKK, as the project leader. Together with my advisor, Associate Professor Dr. Jamila Shafawati from University Malaya. So, what's the problem? Globally, around 80% of municipal, which means domestic and commercial, as well as industrial wastewater, are discharged into the environment without undergoing any preliminary treatment. This increases the global concern of water pollution, as it does not only cause adverse effects on the ecosystems, but also affects human health. It has been reported that around 1.3 trillion gallons of water is used each year by the textile industry to dye clothing materials, indicating that one-fifth of water pollution comes from textile dyes. This project would serve as a solution by producing a composite comprised of activated carbon derived from coconut shell waste and modified with chitosan, which we call as Chito-AC. What is activated carbon? Activated carbon is an absorption medium. Its function is to absorb organic molecules in its micropores. What is it used for actually? Activated carbon is a form of carbon commonly used to filter contaminants from water and air, among many other uses. First, we start off with coconut shell waste, which is then turned into coconut shell charcoal, and then it's activated through physical means or chemical means. And then it's granulated into granulated activated carbon, and then turned into powdered activated carbon. Speaking of activated carbon, there are other uses for activated carbon other than removing contaminants from air and water, such as industrial uses, environmental uses, agricultural uses, and medical uses. Wait, by weighing the coconut shell carbon itself, we add lemon juice into a beaker, check its acidity, the coconut shell carbon into it. Then, stir for 1 hour using a hot plate magnetic stirrer. And then we filter, then dry in an oven at 60 degrees Celsius for 24 hours. And then we rinse with distilled water until the acidity level is neutral. And then we continue with the production of our innovation. After we finish making activated carbon, we dissolve cytosanic acid, which in our case is lemon juice. We heat it at 80 degrees Celsius with continuous stirring for 1 hour using hot plate magnetic stirrer. And then we add activated carbon and shake continuously for 1 hour. And then we adjust its acidity level until neutral. And then we pick up the Chito-AC innovation and place it into a mold to let it harden. It's time to 2 to 10 ppm, which is per million. In terms of words, the 10 ppm solution will contain 10 milligrams of powder in 1 liter of water. And then we check absorbance at 664 nanometers using UV visible spectrophotometer. And then we create a plot graph of absorbance versus the methylene blue concentrations. And then as for product testing, we add the Chito-AC, the 200 milliliters of methylene blue solution, which is at 10 ppm, and put it on shaker for 30 minutes. And then we check the absorbance at 664 nanometers and compare with methylene blue solution without the Chito-AC product. And then we calculate the concentration of methylene blue based on the standard curve. And here is the result. The hero of our project, Chito-AC. Activated carbon derived from coconut shell waste modified with chitosan. Chito-AC works for water treatment. It was observed that the color of the methylene blue solution becomes clearer or more colorless after 30 minutes because of absorption by Chito-AC. The table below shows the initial absorbance and the absorbance after 30 minutes by YI2AC. As we can see, the absorbance dropped to 0.621, or the concentration of methylene blue after 30 minutes dropped from 10 ppm to 4.83 ppm. Samples that we tested. As you can see, the sample on the left shows methylene blue without YI2AC. And as you can see, it's much more dark and thick. However, the sample on the right shows what would happen if methylene blue was with YI2AC. And as you can see, it has become more colorless. So, it has been proven that YI2AC is very cheap and also very cost effective, as shown in the calculation below. Hence, it supports the Waste-to-Wealth initiative. In that, our product also holds high commercialization potential. For example, it can be used in textile industry, the water treatment industry, or in the fish farming or researching industry. And so, that's all from us. Thank you.